بسم الله، الحمد لله، والصلاة والسلام على رسول الله. الطلبة الأعزاء، السلام عليكم ورحمة الله وبركاته، وأهلا ومرحبا بكم في هذا الجزء الثالث من المحور السادس من مادة رسم هندسي 2، والذي بعنوان Assembly Drawing. Three types of assembly drawing we will explain now. First one is called exploded assembly drawing. The parts are separately displayed, but they are aligned according to their assembly positions and sequences. Second, general assembly drawings. All parts in this drawing are drawn in their working position. Third type, detail assembly drawing. All parts are drawn in their working position with the completed dimensions. Here we have, for exploded assembly, one example. Here it is an exploded assembly for all parts, to show all parts exploded, and here we have the finished product. Another example for exploded assembly. Here all parts are here, not assembled, but exploded and ready for to be assembled. General assembly. Here we have the pictorial view for assembly, and here we have orthographic drawing for assembly. Here it is 3D, here it is 2D. Another example for assembly. This machine, for example, only dimensions related to machine's operation are given. Here, different dimensions for the whole machine. Here also, only dimensions related to machine's operation are given in tabulated form, not shown, but it will be given in tabulated form. We have another example here for general assembly. No detail, but general details for part name and numbers, quantity of parts here, and how to be assembled in two views. Here we have detailed assembly, working drawing assembly. All details, or majority of details for all parts with assembly are shown here. Required information in general assembly drawing. All parts drawn in their operation position, part list or bill of materials, BOM, item number, descriptive name, material, quantity required per unit of machine. Third point, we have leader lines with balloons around part numbers. Finally, machining and assembly operations and critical dimensions related to operation of the machine. These are the required information in general assembly drawing. Placing of information used in this course. Here we have assembled part and reference numbers. General note down. Here we have the title block, the part list. Part list, bill of materials used in this course. Locate above or beside the title block. Fill the table from the bottom. Use this template. Here we have number 1, 2, 3, 4, the number, reference number of parts, part name, required number, and material or notes. For example, supports, we have, it is number 1, reference number 1 on the graph, and here we use 2 parts as a support. The material is cast iron. Reference number 2, it is shaft, but we use only 1 as a quantity. Material it is stainless steel. Reference number 3, it is set screw. Number and the quantity, it is 1, and material, it is stainless steel. Here we have an example for another allowable place for bill of materials. This is the another allowable place for BOM, bill of material. It is up and in the up region for the graph or sheet paper, we have here the reference number, here the reference number of the part used, description and title here, and number required or quantity, and here it is some required notes. One example here for number 15, for example, it is a spring. Number 15, it is here. This is spring. Okay. This is part number 15. Number used, quantity is 1. Steps to create assembly drawing. First, analyze geometry and dimensions for all parts in order to understand the assembly steps and overall shape of device or machines. Second, select an appropriate view. Third, choose major parts. That means parts that have several parts assembled on. Finally, draw a view major parts according to a selected viewing. This is point number 4. Point number 5, add detailed view of the remaining parts at their working position. 6, apply section technique where relative positions between adjacent parts and needed to clarify. Number 7, add balloons, notes, and dimensions if any. Number 8, create bill of materials. Some general practices. The number of views can be 1, 2, 3, or more as needed, but it should be minimum. Also, a good viewing direction is that represents all or most of the parts assembled in their working position. We'll take an example now. Selection of necessary views. We have part A with 2 views and part B to be assembled. Student A can make assembly drawing like that, and student B can make assembly drawing like this, which is an appropriate view for assembly drawing. Definitely that one. General practice. Hidden lines usually omit unless they are absolutely necessary to illustrate some important features that the reader might otherwise miss. One example here, hidden line, omit or not. Part A at part B to be assembled. It can be assembled with this manner, like this, or like this. So point number A, it is good because these hidden lines give us information about this hole. Point B or drawing B, it is poor because no information about hidden lines. Point C2, it is poor, it's not good. So the best one to use this representation, and here hidden line give us information about some shapes and features for this part A. Another example here, part A and part B. First example with A to be assembled like that, and B to be assembled like that. Which is better? So A, it is better. B, it is poor. Section technique is usually needed to clarify matching of the parts, part A and part B, the same example. So like that, it is correct, okay. That one, it's better. Use different section line styles for adjacent parts. We have to change inclination here for section lines. If we want to remove colors here, so this representation, it's better with section. Do not draw section lines on sectional view of standard parts. For example, threaded fastener washer, longitudinal cut of solid shaft, pin or key. We'll take example here. We have to make assembly of these 3 parts. So part number 3, it is a standard part. Okay, if we make assembly with this pin, okay, now with section, first possibility, second possibility. So do not make etching and section lines on standard parts. Okay, this one is good, this is poor or wrong as per standards of drawing. Here another example. Okay, the taper pin, it is a standard part. This also shaft for this assembly. If we make assembly, this shaft here and the support and the taper pin, okay, right. Now if we use section, first possibility, second possibility, third and fourth possibility, which is good. Okay, so A, it is poor, not good. B, 2, it is poor. C, it is poor also, but better than A and B. So D, it is the best one. Okay, if we make off the colors, we'll see here. So do not make etching for standard parts here and for the shaft. This one, it is good. This one not. Here we have another example for assembly steps. To make assembly of these 3 parts, we will start by part 1 and 2. Okay, and finally make assembly for the 3rd part. Here we have 3 possibilities. Okay, which is better? Let's check. A, it is poor. Okay, B, it is good. So the pin, it is a standard part, but here we have section, a cross section, not longitudinal section. Okay, so B, it is good, and C, it is good also, but it is better to show details here. If we make off colors, okay, it is better here. Leader line practices. Drawn from the inside of the part to the balloon and placed a fillet circle at the beginning of the line. Here the balloon to indicate the number of this part. Okay, starting from the part. Drawn in oblique direction. Okay, this is for part 2. Here we have an example for making assembly. First part, second part, it is the shaft, housing, cover plate, bearing, cap, screw. To make assembly, we'll start to make assembly shaft with bearing. After that, place these sub-assembly together and make the bearing in its placement. After that, place the cover and finally tighten the screws. Okay, and finish to delete and to remove some lines here and here, here also, okay. Now it is good. Interpreting assembly drawing. To make assembly steps, to analyze function of each part in machine, and to make a design, to understand the design concept. Here we have this assembly. Assembly steps are the following: install bearing to the shaft, install the bearing shaft unit to the housing, install the cover plate, and tighten the screw. Function of main parts. Bearing. The function of the bearing is to support the rotating shaft, and the function of the cover is to control an axial movement and to prevent the bearing unit from rotation. As a design concept, to avoid direct contact between rotating shaft and housing, as well as cover plate by using a bearing and clearance holes. Example 2, leakage prevention unit. The assembly steps are the following. First, wrap a packing to the shaft. Next, install a stud to the casing. Install a stud to the casing here. Third, install the gland ring where it holds. Align the wheel stud. This one, install the gland, this gland as a cover, okay? And align it with the stud holes. Fourth, place the washer and tighten the nut. Last step. Function. First one, packing, preventing the leakage of a fluid inside the casing. So prevent the fluid to go outside from here. Here we have prevention of leakage. Second, gland, press the packing to make it radial, expand and press the shaft surface. So the gland here, make a pressure here and the pressure is transmitted on the shaft. As a design concept, to avoid direct contact between rotating shaft and casing as well as gland rings hole. Third example, fixing part on a shaft. As assemble steps, first place the key on the key seats here. Second step, insert the parts to the shaft until their surfaces lean against the shoulder, here and here. Third step, insert collar and then pin or retaining ring into the groove. Here we have the retaining ring here. Okay, make it in its place. And here we have the pin and the collar. So to prevent translation. As a function, the key, preventing rotational movement of parts. And pin and retaining ring, to prevent axial movement or translation of parts on the shaft. As a design concept, retaining ring can resist lower axial force than collar pin unit. Next example, the assembly steps are the following. First, insert the part on the tapered end of the shaft. Insert the washer, non-standard. This is the washer. Third, tightening the nut and finish the assembly. Function, the washer, improve the distribution, the tightening force on the part. Improve the distribution and make uniform distribution of the tightening force. As a design concept, length of the tapered portion and depth of the tapered hole require a calculation here. Last example, parts having preloaded spring. We have spring in a free length and here the assembly. Assembly steps, first one, insert the spring into the casing. Second, tighten the rod to the spring loader. Third, close the cap and tighten. As a function, spring plunger, transmit a force from rod to spring. Second, keep the spring in a position. As a designer concept here, the spring plunger has a spherical surface contact to the cap. Therefore, the rod can align itself to original position.